Previously, we saw how to project one vector onto another. We projected the longer of these two vectors onto the line of the shorter by drawing a line segment from the tip of this vector to the line of the shorter at a right angle. And our projection vector then was from the common point of the two vectors to the point where that projection line reaches the line of the second vector. Now, we want to estimate the length of the projection as a percent of the length of the projected vector. Well, here's the projected vector, here's the projection. What's the length of the projection as percent of the length of the projected vector? Well, what's longer, the projected vector or the vector projection? Clearly, the vector that you started with. And that's always going to be the case because you're always going to form a right triangle, and the projected vector is going to be the hypotenuse, whereas the projection is going to run along one of the legs. Since the legs are always shorter than the hypotenuse, the projected vector always has to be shorter or not longer than the vector that you're projecting. Okay, now, is this more or less than half the length of this? What do you think? And then, having made that decision, what do you think the percent is? If it's half the length, then it's going to be 50% of the length. Another way of saying it is, if this is 100 miles long, how many miles long is this? If this represents a 100-mile trip, how many miles is this trip? That number would be the percent. So, well, you should do that for this picture. Okay, now I'm going to go ahead and do it. Okay, the vector's this long. If I bring it up here, it's this long, and if I go from there, it looks pretty close to 50%. Okay? Okay. Now, what about here? What's the length of the projected vector as percent of the length of the, what's the length of the projection as a length of the projected vector? Okay, well, here's the projected vector, here's the projection. Okay, let's see, if we bring the projection over here, it looks like a little more than half. I'm going to say maybe 60%. You might have a different opinion. Okay. Now, what about down here? What's the length of the projection as a percent of the length of the projected vector? What's this length as a percent of this length? Again, when I look at this, you should have your own opinion. Get your own opinion before you listen to mine. Just ballpark, just eyeballing it, it looks a little more than half. It looks like it's around 60% again, but let's see. This long, we go to here, and then to here. Yeah, I'd say maybe 65%. Okay. Okay, you're asked to do that. You're also asked to estimate the angles. Excuse me. What's the angle between these two vectors? What's that angle look like? Well, here's 90 degrees. And if I divide that into thirds, then I've got something that looks like 30 degrees here, 60 degrees here, 90 degrees here. And that looks pretty close to a 60-degree angle. That, to me, that looks like if we did a right angle, we'd come around to here. If we took half of this angle here, it'd be about like this. Yeah, I'm ballparking it at 60 degrees. Put a question mark there. That's probably fairly close. And then what do these other angles look like? Well, you need to make your estimates, and you need to do that for all the questions posed on the document. Now, I will say that in this case, the angle is greater than 90 degrees. A 90-degree angle would be here. we have to go further than 90 degrees to get to this angle. So I'm guessing that angle might be around 110, 120, 130 degrees. You make your own judgment.